Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 343 and its whole power n plus 7 to the power of n equals to 26 over 125, and we will solve this problem for the real values of n. So here we need to solve this problem for n belongs to R. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have 343 and we will write this 343 as 7 to the power of 3 and its whole power n, plus here you have 7 to the power of n, and it is equals to 26 over 125. So now in the next step we will change these exponents, and we can use here the nice exponential law. And you know about this law, if we have a to the power of m and its whole power n, it is equals to a to the power of n and its whole power m, and it is equals to a to the power of m times of n. So now we will use here this nice exponential law, so that according to this law we will just interchange these two exponents and it cannot be affected our final answer. So that here we need to interchange these two exponents, so that we will write this equation as 7 to the power of n and its whole cubed, plus here you have 7 to the power of n, it is equals to 26 over 125. So now in the next step we will just convert this nice exponential equation uh, into the cubic form, so that here we will take y equals to 7 to the power of n. So when you will put here y equals 7 to the power of n, then this equation will becomes in the form of y cubed plus y equals to, here you have 26 over 125. So in the next step we will move here 26 over 125 in the left hand side, and we write y cubed plus y minus 26 over 125 equals to 0. So in the next step we will rewrite this equation as y cubed plus y minus, here you have 26 and we will write it as 1 plus 25 over 125, and this whole equation equals to 0. So now we will just separate these two terms, and we write it as y cubed plus y minus 1 over 125 minus 25 over 125, and this whole equation equals to 0. So after this step we will just rearrange the terms, and we write it as y cubed, and here you have minus 1 over 125, and we will just cancel these terms, and you have 1 over 5, because 25 5s are 125, and we will combine this y and 1 over 5, and you write y minus 1 over 5, and this whole equation equals to 0. So now we will first write this equation as y cubed, and we write 1 over 125 as 1 over 5 cubed, and plus here we have y minus 1 over 5, and this whole equation equals to 0. So here we need to use a nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So we will use here this nice cubic formula in the first term. So the first term will becomes in the form of y minus 1 over 5 into y squared and plus y into 1 over 5 and plus 1 over 5 square, and here you have y minus 1 over 5 and this whole equals to 0. So after this step we will make here some simplifications, so that here we will take common y minus 1 over 5 because it is common on both of the terms, and we will get the other terms are y squared plus y over 5 and plus 1 over 25, and here we will take common y minus 1 over 5 and here you get plus 1 and this whole equation equals to 0. So that in the next step we will just rearrange the terms and we write it as y minus 1 over 5 into, here you have y squared plus y over 5, and when you can LCM these terms then you will get here 26 over 25 and this whole equation equals to 0. So in the next step we have two cases. The first case is we take y minus 1 over 5 equals to 0, and the other case is we take y squared plus y over 5 plus 26 over 25 equals to 0. So now first I can focus on this case, and here you have y equals to 1 over 5, and now we move towards this one. So here in order to find the roots of this equation, first we need to write this equation into the standard form, so that we will multiply both of the sides by 25. So when you multiply this equation by 25 then you will get here 25 y squared plus here you have 5 times of y and plus 26, and this whole equation equals to 0. So because in this problem we need to solve the given question for the real values of n, so that here first I can check is this quadratic equation has real roots or not by using the discriminant formula. So you know that here we have the value of a is 25 and b is 5 and c is 26, and our discriminant formula is delta equals to b squared minus 4 times of ac, and now we will put the values of a, b and c here, and you get 5 squared minus 4 times of 25 into 26. So when you multiply these values here, then you will obtain 25 minus when you multiply 4 times of 25 times of 26, then you will get here 2600. So now we subtract 25 by 2600, then you will get here minus 2575 because it is less than 0, so it means that it has no real root. So if it has no real roots then we will reject it this case, and we will just proceed here this case only, and in this case we will back substitute the value of y, and the value of y is 7 to the power of n. So we can move 5 to the upward and you get 5 to the power of minus 1, and now we will take the log on both of the sides and you will get here the output in this form. And now we can use the property of logarithm, so you can just move this exponent in the front of this log and you get n times of log 7 equals to minus 1 times of log 5, and here you have the value of n equals to log 5 over log 7, and here you have negative sign. So now you will use the calculator or logarithm table in order to find the value of these logs, and you have value of log 5 is 0.6989 and the value of log 7 is 0.8450. And when you divide these two values, then finally you will get here the answer of this problem, which is 0.8271. So this is the our final or first real root of this problem, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.